Hello, welcome to Hadoop Introduction part 1. In this video we are going to quickly talk about some of the Apache projects on Hadoop core and extension. So before we get there, in Hadoop, what is MapReduce? Right. MapReduce is a distributed data processing executed in an environment containing large number of commodity hardware cluster machines. So it is scalable, it is cheaper, and it is easy to do large data processing in simple MapReduce algorithms. So when you say commodity hardware, it's not the hardware that we require for running MapReduce program is not specific to any vendor. You can actually buy any machine, and if you attach it to the Hadoop cluster, you are good to go. Right. So the objective here is to define or understand what is MapReduce. MapReduce, again I'm repeating. So it's a distributed data processing executed in a large cluster of commodity hardware machines. Right. So with that, we can go to the next one to see what is Avro. So Hadoop Avro is a serialized system for cross language RPC and persistent data storage. The communication between Hadoop nodes are implemented using low-level RPCs, and the serialization is achieved using writables. So what is serialization here? Serialization is a process where converting the object state into a byte stream that can be sent across the network and be able to deserialize that network stream back into the object. Right? So that's the role it plays in Hadoop ecosystem. The next one is the very important one is called HDFS, the Hadoop Distributed File System. Right? So some of the concepts here are very large to cover it in one slide, but I'm going to give you some high-level hints to correlate when you hear HDFS in Hadoop. So the large file can be stored across multiple disks. Across disk. It doesn't have to sit in one disk because the file system is distributed, right? And it is also designed for streaming access data, and it works with commodity hardware. It doesn't require any special hardware to set up HDFS cluster. Right, and the large block sizes and can be anywhere on the and can be anywhere on the cluster. So the abstraction is achieved at a block level rather than file level, right? So this gives you a flexibility of splitting the block into multiple, splitting the file into block and then storing them across the disk. But for the MapReduce algorithm, it will appear as one single file because the abstraction is achieved at block level rather than file level, right? So this also brings the high availability and fault tolerance to be taken care in. I'm sorry, this block level abstraction brings high availability and fault tolerance feature to it. The configuration on data replication is by default 1:3, which means each block is stored in 3 different locations. Of course, this is configurable. If you want a very high replication factor, you can increase it. So the more you increase, the more space you occupy in disks. Because when you say replication, you're actually copying the same data and keeping it there in the other location as well, so that when one machine goes, you don't lose the data at all. It's going to be still accessed, right? So let's look at the next one. It's called pig. Pig is a high level abstraction for data processing capabilities. So what it means is that the data processing capabilities which are achieved through MapReduce algorithm is abstracted to a higher level, because this reduces the MapReduce program development cycles, and it is to do with MapReduce behind the scenes script execution. So the using pig, you can actually define the data flow in a script language for dealing with large data sets, right? The script language is called pig Latin program. It's actually a set of operations, that it can run on a single machine or on Hadoop cluster. So some of the powerful features in pig include like joins, right? If you have to write a MapReduce program, it joins the operations. It's going to be a nightmare to do that in programming. I mean, of course, it's not nightmare. It's going to be a lot of effort in terms of writing the code and making sure that works. But with the scripting available from pig, it is easy to do it, right? So so when do you choose pig? If you're dealing with a large set of data and your main objective is to do some batch processing, pig is the right choice. So the pig actually it was created at Yahoo, and many companies uses it, and the pig is actually part of Apache open source project as well. So the next one is Hive. So Hive is a distributed data warehouse, right? It gives an SQL-like access to run MapReduce jobs. So this is again a high level abstraction to MapReduce jobs. Instead of MapReduce, jobs are written in programming languages to make sure that the database developers or SQL, query writers can also do the, data analytics using Hive. So this was created originally at Facebook, but this is also part of Apache open source project, and it's actually suitable for integrating with SQL based database. If your solution is having some sort of data being accessed, or it's integrated, it has to be integrated with SQL based database, the Hive is one of the best choice, right? And also to take advantage of the SQL capabilities, which is very easy to understand and write by language independent scripting skills. And the Hive again, it can it runs on local machines to convert the given SQL into one or more MapReduce jobs that ought to be run on actual Hadoop cluster. So you can actually see the power. Someone can just type a SQL query on the local machine that gets converted into MapReduce programs, that ought to be run on the Hadoop cluster. So it's as simple as that. So the next one is a HBase. HBase is actually used as a storage. For column-oriented database, distributed column-oriented database. So it uses HDFS as the file system for the storage, right? And when do you choose HBase? It's like when you are after batch processing or any point query needs, HBase is a good choice. And also, right, best suitable for real-time read-write, random access of very large data sets. It's almost the real time when you're dealing with a large, random access of data. It's not relational and doesn't support SQL, okay? But it overcomes some of the RDBMS limitations of storing very large data in distributed model on commodity hardwares, right? You can actually think that it's actually a cluster of machines storing large set of column-oriented database, which cannot be achieved in regular RDBMS, database application software. So this was created at PowerSet, but this is also quite popular when you are dealing with, a distributed model of, very large data, right? So the next one is Zookeeper. Zookeeper is actually a distributed and high available coordination service, like a workflow for building a distributed solutions, right? So the Zookeeper has many powerful features, like for example, it eliminates the partial failure issues, which lead to a reliable, which lead to a way of building very reliable application, and it is simple to use and it expressive and it is a library, right? It was originally created at Yahoo and then it's part of the Hadoop ecosystem now, and this was also used by many companies, but these days you have other coordination services available. So it really depends what you want to do with respect to your coordination service. And the next one is Hadoop Scoop. So the Scoop is the very efficient, tool to move data between traditional databases and Hadoop file systems, right? So, for example, analytic results can be stored into the databases by Scoop, right? And Scoop import runs on a MapReduce program jobs that connects to RDBMS and often runs parallel jobs to improve performance. So by default it is 4 and that's configurable too. So if you haven't got it clear, let me tell you, the Scoop is actually a tool to move around the data between RDBMS and Hadoop environment, right? So when you do a Scoop import, what happens actually is that underneath it actually runs a MapReduce job, not just one. It runs the MapReduce jobs in parallel to improve the performance. So how many in parallel? By default is 4, but that's again configurable. So there are a lot more to talk about the Hadoop ecosystem projects from Apache Open Source Foundation. So I'll introduce them in future videos, and thanks for watching and listening. If you like my video, subscribe to the button below, and I will keep updating more videos to the channel. Thanks. Bye.